Welcome to Offsite Dirt. This is the Dirt series where we talk about building science and sustainability. Offsite Dirt is a media and event company that showcases current events, technology, offsite solutions, education, and now our newest series, which is sustainability, high performance, and passive house. So really cool building stuff. Today we are joined with Wille. Mark is an expert in high performance and everything that has to do with that area of building. And we have these amazing 3 women with us that are also in this type of space. Mark, I'm going to have you take it away, introduce everyone, and let's get into a little high performance talk.
Awesome. Thank you, Audree. So we have a powerhouse of leaders here today. We're going to go in not in alphabetical order. We're going to go in terms of logos. So in logos, we have Shannon Pendleton of Sanderson Sustainable Design coming to us from New Hope. Say hello, everyone. Followed by that, we have Edie Dillman, and she is with B.PUBLIC coming to us from the great state of New Mexico. Say hello, everyone. And from Holzraum System, we have Ilka Cassidy joining us from somewhere around Philly. And everyone, please say hello. Awesome. So to dive right into the questions so we can get into the substance, we're going to start with Edie. And you can screen share at will because I know you got a whole lot to show us. The question for everyone is, what is classified as high performance?
I'll unmute and jump in. Great question. Thanks for having us. It's great to be here with these rock star women. High performance specifically for us is around a low energy thermal bridge-free structural building envelope. So we're talking today, I think all of us will talk from different angles around high performance and our company's approach or our philosophies around building better. But for us, high performance is really around reducing the energy load for heating and cooling. But we take it quite a bit further that if we're getting into a high performance home, we're also looking at the health long-term of the occupants inside, certainly the health of the materials we're using. So for B.PUBLIC, that is a petroleum-free or a foam-free solution. So we're doing all wood and fiber-based, with exception of our air and weather barriers, and really looking for longevity, sustainability, and again, the quality of that envelope. So that's for us what high performance is.
Unmuting. Perfect. Thank you, Edie. And Ilka, following right up, same question, right? Top of mind, what do you guys classify as high performance?
Mm-hmm. So first, thanks for having us here. It's pretty awesome to be on the screen with everyone. And I can just agree with what Edie just said. So I would think my answer is that traditionally, I would think that high performance was always more perceived as a building or a home that is very energy, like performing very well in the operational energy perspective. So you would say, heating, cooling, all of this, what Edie just mentioned, I would think is more kind of what comes to mind when you hear a high performance building. And there are a lot of things that really take part in that. I think the typical thing that would come to mind is really, okay, we're putting a lot of insulation into a building, and that makes it high performing. But to get to a good operational energy performance, you would also want to have your building airtight and thermal bridge free detailing, and really look at systems. You need energy recovery ventilation and good windows, definitely. And really kind of look at how you generate hot water and your cooling and heating. But then lately, in the last few years, there's definitely a lot more focus on, really carbon like a low carbon footprint. And if you kind of look at it from that perspective, you can't just look at operational energy. You also have to look at the materials that are being used to build the buildings, because there's a lot of energy being spent making materials, lugging them to the site, and also looking at what happens after the building is build's life cycle is being done. So that's definitely kind of a little bit of a broader view, and again, agree with what Edie just said. And what's tricky about it though is that high performance is not really you can't really, there's no concrete measure, right? It's kind of like saying, my building is sustainable or my building is green. It kind of sounds awesome, but how do you really measure? So, and one way to measure that is going through certification programs, and there's a bunch of certification that are out there, and that way you can really just kind of prove that your house is high performing in different ways, whatever the certification, how it lays it out. But, a lot of times homeowners don't necessarily want to spend the extra money to go through certification.
Perfect, Ilka. There's so many touch points to tangent off of that. And Shannon, it's difficult for you because you're following two of your close friends and colleagues. Maybe you'll take us a different direction, but what is classified as high performance for you?
Oh, good question, Mark. Audree, thanks for having me here on Offsite Dirt. Wonderful to be with Edie and Ilka. So I think high performance is people, Mark. I think it's people working in design, in building, and in manufacturing. Because no matter what we're measuring, if the people don't get it done, it doesn't exist. So it's simple building science principles with strict metrics and rigorous testing. It's not basic code. It reaches for the top of the ladder in green building certification. And that's it in a nutshell.
I'm with Edie. That's an applause. All three of your statements, I hope that everyone writes down and listens to them 15 times in a row until you can repeat what Edie, Ilka, and Shannon said. Audree, over to you.
Yeah, and I think what's so great about this conversation is the different perspectives, yet they're all relatable. One is about a building, one is about a function, one's about measuring. All of these different ideas all come into this high performance type of conversation. Not to mention, I love how articulate each one of our guests are, not only about understanding the process, but also identifying that there are measuring tools out there to know how these buildings, how these spaces, how energy is used, how it's measured, why is it so effective. And one of the things that we're also talking about, Mark, is the experience, the occupant experience. So I love that Shannon has talked about not only about the people building it, but it's the human capital of the experience. So right there, I applaud all of you women. It makes me certainly so proud to be amongst you, because there's not a lot of us doing this, not to mention such amazing women in an area that's continuing to grow and evolve. So back to you, Mark. Let's go to our next question and find out a little bit more about each one of these beautiful women's conversation and their companies.
I'm tempted to ask the first question again in different order to see how you guys pivot off of that. That would be so fun, but I'm not going to do it. I'll wait till we're all hanging out, having some chips and dip. So here we go. What is an example of high performance wall assembly? So I'm sure, because I know how y'all work, I'm sure you have some visuals to bring forward. So Edie, you're first.
Great. I'm happy to share screen. And I love that. I love starting with the question about high performance. I was just with a wonderful new client in our design studio this week, and I'd been going on and on and on, and she just stopped me and she said, "Can you just define high performance for me?" So like minds need to dig into this. So thank you for starting there. This is a really great overview of the B.PUBLIC assembly and sort of the benefits for. So there are lots of ways to talk about our work. It is very simply the 6-sided box of a residence, in particular, anything from 1-story to 3-story. And you can see that we've got a floor panel, top panel, and wall panels, and we offer a couple of different R values in this. But what's important for us is that it is robust in many aspects, and you can see that there is an air barrier on the interior. It is fully framed in wood, so we're following light wood code construction straight down the middle. It is fully insulated, and we're using dense packed cellulose, so it is 86% recycled newsprint at this point. It is fully sheathed for each panel, and then wrapped on 6 sides with a weather barrier. And you can see that beautiful rainbow at the bottom of each of those. And that is our Flixo study, proving that it is thermal bridge free. So there are no railroads of energy going in and out of the building, that we're really encapsulating the energy inside and controlling that air barrier and that thermal protection. It is fully structural. I think really important for us, I mentioned this before, it is dense packed cellulose with vapor open membranes on the interior and exterior. And that allows the vapor, if there's vapor inside the wall, to evacuate the structure. So avoiding building science failures. What we really want is to have long-term resilience. We don't want mold, obviously, inside the wall of the building in the cavity. So all of our work has been modeled for performance, not just on thermal comfort, but on the vapor openness. So we've got WWOOFie studies on this. And then looking at climates, we're trying to approach as many climate regions as possible in North America for high performance. So being able to play with sort of our kit of parts, our Lego-like structures, of mixing and matching that R35 wall with an R59 roof panel or an R80, depending on where we are. So really thinking about the material and valuing the material. Building offsite saves almost 100% of material loss in this process. It's a huge piece of what we do in value. And so when you're specifying an envelope that it's appropriate for that region and intended for long-term use. And again, we're talking about smart, high performance, but in an envelope, in craftsmanship and our QC/QA, not by apps on our phones or whirling dervishes in our homes. This really is around great materials. I'm going to stop.
Yes, just stop right there, because I think there's a couple of things that come to mind. Someone that may be kind of more in my role of understanding all of the smart science. So one, Edie, I want to know is, can we use these panels for existing structures? And two, or does it have to be a brand new build in order to use your wall system?
You are so good. Yes, B.PUBLIC is concentrating on new construction specifically. So this is for ground up new construction. We are doing some work where, I don't want to say addition, Audree, but maybe a second story over an existing, so that we're really looking at that envelope as continuous. But all new construction. And we're doing anything from single family homes to multifamily 3 stories above podiums. So think about what you think of as an envelope can be an ADU in a backyard, or it could be, a row of townhomes.
And just for the people listening, an ADU is an accessory dwelling unit. Usually it's anywhere from 300 square feet to 900 square feet. And I'm guessing the reason why we're doing new construction is, one, again, like Ilka said, and Shannon, is that we are trying to utilize this quality control system, right? We're looking to measure the energy. We're looking to be able to create a system that measures these tools in order to be effective, correct?
Yep, it's data driven. Absolutely.
Perfect. Thank you. That was beautiful. Thank you for sharing that information. Mark, back to you.
Okay. Okay. So We're back to the top of the list here, and the same question applies, Ilka. Thank you so much, Edie. I've got more questions, but we're not going to get into them today. What is an example of high performance wall assembly with your system, and how you create this before it's ever built as well?
So I'm going to share my screen as well, and what I'm going to show is a wall assembly that we have been using since even before we formed Holzraum System. We are working on other panels as well, dependent on location of the project and availability of materials and everything. So we're trying to be very flexible, but similar to Edie, we're totally dedicated to assemblies that are vapor open and foam free, or wood-based mostly. So, and this is a assembly that we really like. We call it the XP20. So, and similar to Edie, what we do is kind of connecting a wall and a roof panel as well. So the roof panel is very similar to the wall. So going through the assembly, we from the inside out. So what we're looking at is basically we don't really see the drywall, but this is where the drywall would be. So basically the finish on the inside, and that is kept off the, let me just turn this off. It's the exterior, sorry, this here. So I am in the wrong model. I apologize.
So I think the first thing people see when they look at this is that you have zip system running on the interior facing. That is not a common thing to see. So there's a reason for that.
Exactly. So now that I have my interior finishes turned off here, we can see the zip sheathing pretty clearly. And I guess the one important thing to this assembly is that it's definitely developed with the factory in mind. So the layering and the way you assemble it is optimized for a factory. It's a little harder to do this on site. And this is optimized towards basically limiting the amount of layers that you use. So almost every one of those layers actually has more than one function. So the zip sheathing or any other structure sheathing that is airtight here, acts as the structural zip sheathing or structural sheathing, the air barrier, and also a vapor retarder. So this is also optimized for heating dominated climates. Every time we go a little bit into a warmer climate, we do also do Wolf analysis to see if it's still a safe assembly for that particular climate. But this is, so we're mostly working climate zone 4 or 5, and this works really, really well because the moisture, the vapor drive always goes towards the cold side of the wall. So by having a vapor retarder on the inside, again, that also acts as an air barrier, really reduces the amount of moisture, the vapor that goes into the wall. So that's kind of the layering here. And because it is the air barrier, we do need to protect it. So that's why we have a surface cavity here on the inside, which turn off. And then going further outward, you can see this is basically also just a very basic 2x wall that's filled with either dense packed cellulose or hand bats. Lately, we've been using hand bats, but it's from this perspective, it's fairly a standard wall, right? So and then if we turn it around and look at it from the outside. Again, there is a layer, a wood fiber insulation layer here that also acts, covers several functions. So here it acts as the exterior insulation, which makes this wall assembly also thermal bridge free. It also holds, it's stiff enough to hold the insulation on the inside. So we don't need another a layer of sheathing here. So it's basically the sheathing that holds the insulation in. It can act as a WRB. It has a coating on it, but we also always add another WRB on top of it because once you panelize that, you can't really take advantage of those. They come in tongue and roof formats. So, but once you panelize this, you have vertical and horizontal seams, and you have to cover those with a WRB. So, and the trick or the great thing about this is that it's very, very vapor open. Wood fiber insulation is very vapor open. So the potential to dry out is given at any moment if there is any kind of moisture buildup in the walls. So you still want to do, some ridge-free detailing to avoid condensation. But if condensation happens, it can dry out really, really quickly. And in order to assure that that happens, you definitely need a rain screen on the outside. So this is what I'm showing here. So the next thing I wanted to share really quickly is this wall. This assembly, which is basically the same wall assembly, but what we started doing quite a bit in projects is to actually combine it with CLT roof and floor panels. So we've been developing quite a bit around hybrid solutions, again, all wood based, but this is kind of a full system that can integrate either way with different components. And then the last thing I wanted to show really quickly, I'm going to turn these off, is this little, we call it a little nugget, which is actually a detail out of a project. And what I wanted to show here is that what's also important, that's what we talked about before, is not just layering more insulation onto, components, but it's really, really important to really look at how everything gets connected, because airtightness is super, super important. If I go take this off, you can see that, again, the zip sheathing here is our air barrier, but how do you really connect that in an airtight way? So what we do is we have these control layer transitions that I can turn on and off here. Those are membrane leaders, and it's really, really important to think about those before, like in your kind of sequencing of the building. In this case, we have a structural timber frame here. So once you really have to think about, because once the timber frame is there and the panels are on top of it, there's no way to really reach this little corner, because this is the air barrier, this is the air barrier. Somehow you have to connect that. So in order to do that, you basically have to kind of wrap membranes beforehand and be really conscious of sequencing. So yeah, that's kind of what I wanted to share.
Okay, Ilka, I have a couple of questions for you.
Mm-hmm.
One is this only restricted to one plan design, or can you take any type of architectural plans and use them for this system?
Yeah, that's kind of what we do. So we're we work with a lot of more complicated, larger buildings that people come to us with, where the architect, the owner have very, very good intentions of making this a high performance or a passive house, but they might not have that experience to really make that fairly, high-end, complicated building a passive house. And that's what we do, where we definitely reuse kind of standard details, or the approaches are always the same, depending on wall type. I mean, this is always the same idea. Okay, we have this transition here. How do we connect those? But every building is basically different, and it's kind of a team effort to work through that. And we find these visualization tools very, very helpful with doing that.
Oh, I think it's fantastic. I think it's easier to understand what kind of system we're talking about and how comprehensive it is, in order for us to really see the detail that goes into this. And then one other last question before we go to Shannon. The last question is, because you're building with all these different layers and these, these really amazing products, when a client comes to you and they're like, I want to do a passive house, or I want to actually have an energy efficient home, and they bring the plans to you, how are you able to then predict the energy level? Like, do you come in and say, this is going to be this R50, this equation first, and then build after? Or is it the build process first and then the testing after?
Mm-hmm. Well, it really depends on what the priorities are, because if a client comes to us and says, okay, my goal is certification, then we would go about it. And I would do kind of a quick energy model. I use Wille Passive to just really early on start working with them and just kind of look at what they have and say, okay, this is, you can go for certification with this layout with, kind of an assumed wall assembly that is, cost effective in your area, or it's like you're so far off. Either you really have to change the design, or you have to really boost up your insulation levels, or your priority is not to go through certification, which is fine too. For some buildings, it just doesn't work. All your views are to the north. You don't want to ruin your views just to, get a certification plaque. So, so that's kind of, and if they come and say, this is our building, we don't really want to change the design, then we basically look at, okay, this is the assembly that works for you, that is cost effective. And then I still do energy modeling because that is always really helpful, but even to determine the systems, but it's kind of a little bit the other way around.
So before you take the image off, when you look at the work of Edie and her team, Ilka and her team, and what we'll see next from Shannon, is this image shows a great deal. A lot of people that are following code that just are using the word continuous. They might not exactly know what they're achieving. They might have used an R5 on one project, and so that's their go-to. But when you look at this detailed nugget, it's a beautiful phrase, you're seeing continuity between the transition areas. And so if you're not going to have continuity and you're just using continuous whatever, your continuous whatever is going to deliver whatever. But the continuity here is all detailed based on the look and the form that the client wants, but giving them the comfort that they never knew they can have. And that continuity is no callbacks and nothing but happy feet, heads, and everything in between, because it's her thermal pants, it's her boots, it's her sweater, it's her hoodie and her hat, with her completely belts and suspenders wrapped tight and warm. Love it. Shannon, you got a tough one. Ilka had some wicked, awesome visuals there following Edie. So coming to you. Can I
just add one little thing, because I just see that it might be a little confusing. So this would all be filled with insulation here, which is not being shown here. So this is all filled with insulation, and then this is kind of wrapping around it, just to clarify.
Right. My eyes saw that as the continuity jumping in between, and then the service areas or venting areas beyond that were also consistent. So Shannon, you can't use it depends, because after 35 minutes of presenting, Ilka dropped it. So she owes us dinner. But jumping to the question, and I know you have it, and look at this. Oh my gosh. You don't even need to hear the question. You see it in front of you. Shannon, what is an example of a high performance wall assembly?
Well, I'm just going to pick up where you left off, Mark, which is continuity, right? Continuity in the team, continuity in the goals, and continuity in the construction, and then the testing. So what I'm showing right here is a multifamily passive house for a Silver Green project, and the wall types and some of the construction photos that relate to those wall types. And you can see the insulation levels that we move through from foundation to roof. So our business model at Sanderson Sustainable Design helps define those goals, determine the metrics, and then build the teams to hit those goals. Often that means education and integrating passive house, zero energy, and carbon neutrality into an architect's existing workflows. Sometimes I play that role, and sometimes I play the role of simply a sustainability consultant. But these brilliant prefab systems that Ilka has showed and that Edie has showed are really amazing. They not only make it possible to do this because it is possible on site, but it makes it predictable. And when I say it, I mean all of it: the budget, the schedule, the performance, the testing. So this shows the strategy and how prefab integrates with all those on-site elements of construction. And if you look at these photos, you can see we've got a full stone veneer, we have custom windows, but we prefab the interior walls, the floor plates, the exterior walls, the roof trusses, and even interior groin vaulted ceilings. So we had a real combination of elements. And, you know, full disclosure, Holzraum did work on this project and delivered really, really beautiful, airtight, prefabricated wall systems with pre-installed windows. So, like I said, when you integrate that in your workflow, you start with a really big leg up. So what's great to know if you're new to this is how will it affect your workflow? So I'm going to show you another page outside of this one, which is, oh, I hope this little window wasn't in front of that the whole time. But this page shows all the items in red on the left, which were added to our workflow. So we had all these dates on the project timeline, and we had to add an early packaged release for window and door orders, which had to happen even before we were under contract for everything, which was a little bit of a shift. If you start early enough and integrate this early enough, you can get under contract before then, but we were a little behind the eight ball. You can do it either way. It's never too late unless you're already committed to buying everything and delivering it on site. And then we had our window delivery to the robotics manufacturing facility, which was Blueprint. We had a verifier kickoff meeting and additional blower door tests. So those were the things in the timeline. And then for the prefab challenges, I think a lot of these were really a result of the project itself, right? We had northern views and southern privacy, which is not typical of a passive house. And then we also had a full stone veneer. So back to what Ilka and Edie are both talking about in terms of being vapor open. We wanted to be vapor open on both sides because we know in our climate, which is everything, where you're building is where you start. We want to make sure that if we have a vapor drive to the interior or exterior, depending upon when we're heating in our cooling season or cooling in our heating season, that we are going to dry out in both directions. So bi-directional vapor diffusion. Love that phrase. It's a lot of words, but it's a simple concept. Let it dry out on both sides. So what else can I tell you about this project? It's not too different, right? If you can see this workflow and you can see these details, it's not that different. And it really helps bring to anyone's workflow a leg up. It makes it faster. It makes it cleaner. It takes out the change orders, and it keeps everybody on the same page from the very beginning. So we had the builder on board early. We had the prefab in early, and we had what's kind of most important, an owner who's on board with all of it.
A well-informed owner is a happy client and a great referral stream. Shannon, this is a big one. You guys all work with a variety of clients in many different climate zones, and you all do very attractive work, and you do high performance work. And I think it's important to know the response time that comes is also because of your levels of experience and the fact that you know what to predict is coming. I also think it's important to have the assets that when you guys are contacted in the beginning, you're stressing the team and coming together with the team. So the products you use are a part of it, but the process is driven by the three of you and the people that you share the offices work. It's great.
Thanks, Mark.
I think it's amazing that if people are not thinking about how they live, if they're not thinking about how they construct, it's the conversation to start having. Everything that I do with Modular SureSite is an offsite solution. How are we creating better, faster, more efficient ways to build and higher quality parts to build? Each one of these companies achieve all of those. And it's great to be able to understand it a little more, research it a little more. We will have in the show notes each one of their contacts information so that maybe they're closer to where you are at. You maybe be able to visit one of their sites or be able to see their projects. But as we're learning today, it is a system that is not only sophisticated, but it's doable. Right, Mark?
It's been done, and it's being done, right? So predictable. All these houses are built on the computer screens in front of these talented people. They're all built there. And then it gets portioned out. And those extra testing and those extra verifications happen before a stick hits the ground. It's very unique that all the projects that they presented today took into the fact of the operational carbon and the embodied carbon of the materials. That's not usually an ask of the client, but it's a deliverable with the attributes of performance that they're building in. So people might not have ever said the word healthy or green or light impact on the planet, but as a result, at the end, when they're feeling healthy in their house and they know they didn't do torment to what Mother Nature has for us, then we could be blessed with that.
Absolutely. I couldn't agree more. And I think it's always about showing value. And each one of these companies have their heart in the right place because they are worried about the equity of their client and wealth, or not wealth, wellness, for that being that's going to be in their type of structure. So with that, we're going to close out. I'm just going to ask one last question to each one of these women. I'm going to start with you, Shannon. What attracted you to doing high performance?
Oh, I've always been very interested in sustainable design. And when I first started, the common phrase from all my builder friends who taught me as I was learning how to draw what they were going to build, their common refrain was, it always costs more and you can't prove it. And way back then in the early 90s, they were right. But now with building science, with high performance, with metrics and testing applied to all of these principles, we can prove it. And we've been doing it for so long that it doesn't have to cost more. So we've tunneled through the cost barrier and we've created a return on investment. And not only that, but superior comfort and health. So yes, you're helping the planet. We all want to do that. That's a given. But to have your greatest investment now put money back in your pocket and health back in your life, that's a big deal. We've got clients that leave their inhalers at the door. So, if you've got a bad case of asthma, you aren't going to just be non-toxic because it's the right thing to do. You're going to do it because you're in an airtight house that gives you a return on investment and you want it to be healthy. You want it to be clean. The other reason I do it is owners don't get caught in the middle between the architect and the builder. It's not me saying to the owner, I did my job and I did it right. And it's not the builder saying to the owner, I did my job and I did it right. There's a third-party certification system. They are proving you got what you paid for. And there's another set of eyes on everything. You saw how complex some of these details can be. Another set of eyes that is objective and that has testing to go with it. is really required when you're building the largest investment you'll probably make in your lifetime.
Well said. Ilka, what attracted you to this type of building?
Mhm. So you probably heard that I'm from Germany. So I grew up in Germany, and I feel like it was always around me, like even in school. I mean, just the awareness of just, you know, using different trash cans and just being aware of energy usage. I don't know. I mean, the energy costs are a lot higher in Germany. So I grew up with my mom always telling me, turn off the lights whenever you're not in the room. We grew up with radiators in each room. And if you don't spend time in that room, you turn it off. Right. So I feel like I just grew up with it, and it was all around me. And once I got into architecture, I was just a little frustrated with the way buildings are being built. And then, you know, just the way of building here was very unfamiliar to me in general. And then I just realized that it can be done different, and it has to be done different. I think that's the biggest thing. I always, in the beginning, I mean, I started with Passive House so early where nobody even, you know, it was like, why are you doing this? And I always knew it has to go that way. Like eventually there's really no way around it. So that's basically how I ended up here. And I really like that work.
And we're glad you're here and you're making a huge impact. Edie, what attracted you to this industry and being able to build this sophisticated product?
Well, I don't know about you guys, but I feel like there's so much wrong in this world, right? And with this high performance, passive house, building better, integrated teams, there's so much good. And so that's what attracted me. That there is something we can do. I'm a longtime entrepreneur. I wouldn't say serial, because that sounds a little scary. But I come at it from the marketing and the business side. And it's a no-brainer that we can create green jobs. We can train people in the trades to build to what is code now, but beyond code. And I think bringing back the pride in craftsmanship and building past sort of policy, but for doing the right thing. So we started this company to do the right thing. And part of that, I think everybody's spoken on, is having predictability about this. This is not new, right? There are a lot of people who are practicing this way around the world, but it's not offered widely. So it's really, for me, that was the spark of, we can offer this to really any size project. And for a lot of people, it's been rarefied, and you have to have a highly specialized team. Well, so our company decided to invest in that so we could offer a kit of parts to give opportunity, give that data, give someone a choice around what they want to invest in. Again, Shannon just said it. It's like the number one largest investment we will make in our lifetimes, and it's an investment in health. So for me, it was, I can do good. I don't have to design it because I'm not an architect or building scientist, but I believe in the data. And so I'm here to push it forward. That's what did it for me.
Wow.
Good news, just good news. Got to share it.
I love that. I love that. And Mark, you being one of the hosts, not only on Offsite Dirt, but many other programs, and writing about it, and really your passion, what attracted you to high performance?
Well, I was duped. I don't know if I've shared the story with everyone on here before, because we've all had hundreds of conversations. I was duped. I was taking a lot of free courses. We used to have that, and they were on Tuesdays, they were on Thursdays, and they were on Saturday. And I was also, besides rehabbing, I was working on green and sustainable stores. It was a chain that doesn't exist anymore. And, I'm reaching out to all the people in weatherization and whatnot, because that was more of the terminology then. That this guy came along and said, you gotta check out this passive house stuff, because all you need is a blow dryer and you can heat your house. And I was like, well, that's amazing. Well, come to find out, there's incredible mechanical engineers and there's this woofy modeling thing. I'm like, what? There's all these other things that are involved. And then a fella came over from Ireland. He was trained under the PHI standard of passive house. His name is Tomás O'Leary. And I got to meet him, and I tried to get a lot of people together. Sometimes meetings are not successful. Sometimes you have two people, then we're there for two. Those are two important people. We had 12 people from the meeting, came all the way from Ireland for 12 people. But then right after that, I went to New York and took his first training. So the man has an incredible gift of gab. He dresses a little bit better than me, so he has a nice style that way. But I'll tell you what, it wasn't just him, it was everyone along the way. I met Katrin about the same time, and we all know these leaders that are out there. And so I was duped. I was duped into the blow dryer, and I stayed for the people that are making a difference in lives of people that they'll never meet. I've seen each of you present to foreign groups where you know some people in the audience, and people are telling stories of these little anecdotes that they learned about attributes of building. And we're never going to meet the people we impact, but there's a lot of trees being planted for other people to nourish from.
Wow. And with that, we are going to close. Thank you, Edie. Thank you, Ilka. Thank you, Shannon. And thank you, Mark, for this intelligent conversation about high performance and offsite construction. It makes me excited to see that there's another opportunity for someone to learn something, to build differently, and to live better. So with that, thank you, everyone.